Hi, in this lecture, you will learn how you can use Lambda functions as inner functions in order to make closure or factory functions in Python. So let's create here a new separate file and I'll name it lambda underscore closures dot py and hit enter. We have learned about closure concept, so let me tell you the scenario. We are going to find the exponent. So for this purpose, in the outer function we will ask user to enter the weight or the power of the number, and then in the inner function we will ask user to enter the number and we will multiply the number with the weight and will return the answer simply. But we will implement this logic with the help of lambda functions. So let's create here our outer or enclosing function. Just write here def and I'll name it num underscore weight. Okay, so this outer function is going to take a weight or power from the user, and obviously let's write here power. Now inside this function, first of all I'll use a regular function, and then in the next step we are going to implement the same logic with the help of lambda in order to make everything easy for you. So just write here a regular function, and the name of this function will be number, because this function will ask user to enter the number, and I'll save the number in this num variable. And now inside this function I'll use the exponent sign and I'll multiply the number with the power. So just write here return and then number raised to the power. Okay, let's save it. And now outside this number function I'll return it. So just write here return and then number. Okay, so it's our closure function, and now let's call our number underscore weight function. So number underscore weight, and let's find the cube of number. So just write here 3, and I'm going to save it in this num underscore cube variable, or it will be a function object basically. And now I'll say a number underscore cube, and let's find the cube of maybe 10, which we know 1000, and I'll save the result in this result result variable, because here as you can see this function is returning me an integer value. So I'll save it in this result and I'll print it. Okay, so just write your print result. Okay, let's save it and let's run it, and we got 1000. So let's type here maybe 40 and let's run it, and now we got 64,000. Yes, so I hope you have understood the logic. And now instead of this number function, let's use a lambda function. So let's remove it, and first of all I'll say lambda lambda, and this lambda will accept an argument which will be the number. So just write here a num parameter and then put colon, and I'll return the exponent. So just write here number double asterisk signs and then power. Okay, and now we need to actually return a function. So here as you can see we are returning a function. So instead of writing the return and number here, I'll remove it, and before this lambda keyword I'll write return and return, because we know very well that this lambda function returns a function object which we have discussed in the previous lecture. So I'm directly returning it. So as you can see that with only one line I'm making a closure function. So let's remove this, and now let's save it and let's run it, and we got our same output. So first of all Python will save this lambda object in this number underscore cube, because this num underscore weight function is returning a function object, and then I'm passing here the 40. So this 40 will be accepted right here in this num variable, and we are simply calculating the answer, and this lambda function will return the answer of this expression, and I'm receiving that answer in this result variable, and I'm simply printing it. So if you don't understand the logic, you can actually debug it and you can observe how values are being assigned to each variable. And in the next lecture we will talk about Lambda decorators. But before I actually end this lecture, let me give you some homework. So in the previous lectures we have written this closure. Now your task is to implement the same logic of this closure with Lambda function. So you need to replace this regular function with the Lambda functions. And I hope you will enjoy this task, and I'll see you in the next lecture. Bye bye.